Hey Vex Nation, welcome back to the 2026-2027 video walkthrough of the VexIQ Robotics Competition HeroBot. In the second part of the series, we're going to discuss some of the shortcomings of this year's HeroBot and how teams might look to improve the design and performance of the robot should they choose to field it. If you haven't checked out the reveal video for this year's game Level Up, or read the game manual, this might be a good time to do so. In the last video, we gave a brief overview of our goals for the HeroBot program, about how this is intended to provide students an accessible means to develop an understanding of the game and how to play it. The HeroBot is also intended to be a starting point that teams use to iterate upon and make their own over the course of the design process. It is highly encouraged that teams work to modify the HeroBot to better fit their design goals, and this video will serve as a platform to discuss how you might approach what to change. Flop is built on top of a fairly standard drivetrain for the VexIQ competition, and while it's unlikely major changes will need to be implemented here, teams may choose to explore different gearing options to optimize the time spent driving in Level Up. Because the possession limit is one beanbag, cycle time will be critical. If you can save time while driving, it may allow you to eke out one less bag at the end of the match. The intake is similarly optimized within the boundaries of the IQ competition kit. If teams have other parts available to them, they might explore different options for the rollers on the mechanism, or choose to re-gear this mechanism as well. Teams may also look at making the entire mechanism wider. It won't help pick up more game pieces, remember that possession limit, but it will help with lining up to game pieces and require less driving or autonomous precision in order to intake a game piece. A big area for improvement lies within the arm on flop. The robot got its name from the way the arm flops over the top of the robot during travel. When it does this, the robot base is somewhat unstable. Teams will probably want to explore ways to make the robot more stable during the travel of the arm. Accomplishing this will remove some risk involved when scoring, making sure the robot cannot tip itself over while the center of gravity shifts during the arm's travel. The last area to highlight with Flop is how you might choose to integrate sensors and more complex programming to improve performance. Teams may want to look at adding a gyro sensor to the robot to assist in autonomous skills, or they may choose to add a vision sensor to the front of the robot to detect the color of beanbags as the robot navigates the field. Any competitive robot can benefit from sensors and more in-depth software, and Flop is no different. We can't wait to see teams bringing flops, and especially modified flops, to the field this year. Thanks for watching, and be sure to like, comment, subscribe, and stay tuned for more Vex Robotics content.